Here today, and maybe you've guessed it, maybe you haven't, but today's video is on finding surface area, and specifically finding surface area on cylinders, which is why you can see I've got lots of different pictures of cylinders that you can see here. So first of all, surface area, we've spent quite a few weeks now, a couple of weeks, looking at finding the area of different types of polygons, right? We found the area of hexagons and octagons, and we also looked at last week finding the area of circles and the circumference, which is the distance around a circle. So when I say finding the surface area, that means we're finding the area of a three-dimensional object. Okay, so three-dimensional objects can be made up of lots of different shapes, right? If you think about a Kleenex box is made up of rectangles. We have all sorts of three-dimensional shapes, right? Many of our buildings that we live in are all made up of different types of shapes. All right, so today I'm just going to focus on finding the surface area of a cylinder. So again, you can see lots of different cylinders here. Some of these are not cylinders, right? Like this figure right here. However, it's made up of cylinders. All right, so again, looking here, I got some different cylinders. Here's that wonderful, Amazon speaker that many of us have. Here's a candle. This is something we've all been coveting lately, right? Toilet paper. Definitely made up of a cylinder. In fact, if you look at that, there's two different cylinders. Here's a building, right? We like to make buildings that are cylindrical shaped. In fact, this building, this is called the Bonaventure Hotel. It's in Los Angeles. And not to make anyone feel bad, but this was where my senior prom, actually not my senior prom, when I went to in 11th grade, happened at this building. Pretty cool building in LA. This is the elevator there, also a cylinder. I remember being just fascinated by it when I went. And again, back to that speaker cylinder. So, let me go back to it. How do I find the area of this cylinder? So I have to first think about if I took this apart, I'm going to end up with two circles, as you can see here. I'm going to have the top circle, I'm going to have the bottom circle, and then that piece right here has been wrapped around those two circles. So when I'm finding the surface area of this cylinder, I'm really finding the surface area of, I'm finding the area of a circle, right? And I'm finding the area of another circle, and I'm finding the area of a rectangle. Okay, so the question is how then, and then I'm going to add those up, right? So I'm going to have to go back and, I'm going to go back and add these, and I'm going to add them again, and I'm going to end up with and I'm going to abbreviate it as SA, standing for my surface area. Okay, so we do need to know a few things before I can do that. So for example, I would need to know either the radius or the diameter. So I'm going to do a problem where I'm given the diameter. Okay, so let's say I'm given that the diameter of this cylinder is, I'm going to go ahead and say it's 10. And I'm given the height of this cylinder, and I'm going to say that the height of this cylinder is 14. And I'm not giving units here, so this could be, probably in this case, it would be centimeters if I was talking about that to keep it to scale, but I'm not going to worry about the units. All right, so we already know how to find the area of a circle. The area of a circle is pi times radius squared. So if I'm going to find the area of this circle, I'm going to need to do pi, and then it's going to be the radius. So what would be the radius? They didn't give me the radius, right? They gave me the diameter, but I can find the radius. The radius is going to be half of that diameter, so my radius will be 5. So it will be 5 squared. And I'm going to go ahead and have the same. So I'm going to go ahead and plus that to, now I have to find, that's just going to be the same thing, correct? So I'm going to have, again, this is going to be pi times 5 squared. And that's going to be, again, added to. Now I've got to find the area of this rectangle. Okay, now we already know the area of a rectangle is its base times height, or its length times width. Over here I'm noticing I already have that this is 10 and I have that this is 14. So if I think about taking this and just unfolding it, it's going to end up being this rectangle. This length right here is going to be 14. But what would be this length right here? Since it's being wrapped around that circle, yes, some of you have already guessed it, okay, the distance around that circle is the circumference, okay? And the circumference of a circle, some of you might remember from last week, is 2, can I do that 2? Let's see, 2 times pi times the radius. All right, so 2 times pi times r. So I'm going to go back and do that. That's going to be this length. That is going to be 2 times pi, so I'm going to just put 2. Oops, nope, that's not what I wanted right there. Next to pi, 2 times pi times my radius, which is 5. So I'm going to times that by 5. Okay, so I'm not done though. I got to be careful, all right? My actual area of this will be 14 times 2 times pi times 5. So I'm going to first do 2 times 5, which is 10, and I'm going to times that by 14, which would be 140, and that would be times pi. But I'm leaving, you might notice, I'm leaving it as just pi. I'm not timesing it by that 3.14. So I'm just going to put right here, that's going to be 140 pi. And that is going to end up equaling my, oops, that's not what I wanted, my surface area. Okay, now I'm not quite finished. I'm going to need to go back and actually add those areas together. So thankfully this is pretty easy to find. 5 squared, 5 times 5, 25 times pi. I have another 25 times pi, and then I have 140 pi. So think of that pi, again we do know what it is, it's 3.19, but lots of mathematicians like to leave it in what is called the pi form, meaning I'm not going to multiply it by 3.14. I'm just going to leave it times pi. Why is that? I don't really know, okay? But they do like to do that. It's a little bit simpler, okay? It's a little bit easier to work with. So I'm going to do that as well. So this was 25 pi, this was 25 pi plus 140 pi. Again, when I add with the variable doesn't change. So I'm going to have 50 pi plus 140 pi, which is going to end up being 190 pi. So I'm going to end up with 190 pi, and that is going to equal my surface area. All right. So that is finding the area of a cylinder. Again, when I'm thinking about it, I want to think of it as it's being broken up into those two circles. So pi times radius squared plus a pi times radius squared plus the area of that rectangle. So in general and in closing of this fabulous video that I hope you've enjoyed, okay, in general, how do I find the surface area of a cylinder? I am going to find the area of one of those circles, which is pi r squared, plus the area of that same circle, pi r squared, and it's going to be added to the area of the rectangle, which is 2 pi r times h, right here, is going to equal my surface area. I don't actually need that last symbol, just surface area. If you are to look online, you're going to see that some mathematicians, right, have simplified this, meaning they've added these three together, but then they've factored out, okay, a common factor. I'm not going to do that because I find it much simpler just to think about it as the two circles plus the area of the rectangle, and then I add those together. In general as well, leave your answer in what I called the pi form, meaning don't multiply it by pi unless the problem specifically asks you to do so. All right, I hope you have enjoyed this video that I have made for you. Again, this might be a good thing right here to write down, okay, so that you have it written down as you start to do the problems on finding the surface area of a cylinder. And as always, I am available. Okay, you may call me. My cell number has been posted many times on Google Classroom. You may send me an email, you may text me, and I can help you with any problem. And I miss you guys all a lot. All right.